Welcome to lesson 1.2, where we do some more limits, talk about a little bit more continuity, and do intermediate value theorem. So we're going to talk about some more limits first. The first kind of limit we want to talk about in today's lesson is when your limit gives you an indeterminate form. This is an important vocabulary word that's going to come up several times. There's a couple different forms we talk about. The one we're focusing on today is 0 over 0. That's our first indeterminate form. So if we look at this first example, if I were to plug 0 into this right away with my direct substitution, I would get 0 over 0 times 0 plus 1, which is my indeterminate form. If you get an indeterminate form, what that usually means is you can go back, do some algebra, simplify a little bit, and then it will work. So if I look at this one, my algebra is to simplify my x's. So if I simplify that, I now have 1 over x plus 1. And now if I do direct substitution, I get an answer. It works. Couple things. Number one, you do not need to simplify that. You can leave that as your answer and you're fine. You will get full points on the free response. Second, you do need to write this right there. You need to write your limit in every single line of work until you do your direct substitution, or you will lose points. So let's try it with this one. With this one, we notice that the denominator is difference of squares. So I factor out the denominator, and I get those cancel. So I get 1 over x plus 2, and now I can do my direct substitution, get my answer. Now, just one note, a reminder from rational functions. If you ever have a factor on top and a factor on bottom cancel each other out, that's going to be a hole in your graph, which would be a removable discontinuity. Okay, let's do this one. This one, there is a way to factor this to like x minus 1, x squared, blah, 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 blah. It's difference of cubes. But let's say we get to the AP test, we see this problem, and we're like, oh snap, I do not remember difference of cubes. I don't remember how to factor that out. Well, instead of thinking of factoring and then simplifying, think of this as division. This is x cubed minus 1 divided by x minus 1. Now, real quick reminder for division, you always need to put some placeholders in there for the terms you don't have. It's kind of like if I wanted to write 2020 as 22. It doesn't work. I need my 0 placeholders in there. Now we can do a review of long division of polynomials from secondary math 3. So I think x times what gives me x cubed? X times what gives me x cubed? Well, that's x squared. I'm going to distribute my x squared back into there. So x times x squared is x cubed. X squared times negative 1 is negative x squared. So I've got that. Now, next thing, I need to change the signs on everything. If you remember from elementary school, when you did long division of numbers, you would always subtract the number. That's what we're doing here. We're just distributing the negative through everything. X cubed minus x cubed cancels out. X squared plus x squared is x squared. Bring down our next term. Do it all over again. X times what equals x squared? That's x. Distribute it in, x times x is x squared, x times negative 1 is negative x. Change my signs. Those cancel. I have a positive x. Bring down my negative 1. And last time, do the same thing all over again. X times what is x? Well, 1, multiply it through, 1 times x is x, 1 times -1 is -1, change the signs on everything, and I see they both cancel out and I get 0. So basically what this whole division thing is saying is we can rewrite this as a multiplication statement like this. So I took this division, and instead of saying x cubed minus 1 divided by x minus 1, I can now change this into a multiplication statement. X minus 1 times x squared plus x plus 1 equals x cubed minus 1. So I am actually going to take this part and substitute it in for that part. So I've got limit as x goes to 1 of x minus 1 times x squared plus x plus 1 all over x minus 1. And now I see I have factors cancel. So I'm left with x squared plus x plus 1, which I can now do my direct substitution. Okay, in the next video, we'll do these last two problems.